Hi everybody, my name is Marta and I'm a PhD student at the University of Toronto, and I'm sorry I cannot be with you today in Japan, but thankfully due to technology I can call you all the way from across the world. So I hope you're having a wonderful workshop so far. Today I'm going to tell you about ORGANA, a system that we've been building over here at the University of Toronto for the last few years, and ORGANA is a robot assistant that can help automate different chemistry experiments and characterize the products that are made. So ORGANA is a robot assistant that consists of multiple different components, and I'll go into what all of those components are, but the first experiment that we show ORGANA on is a electrochemistry experiment where it requires multiple different steps, including electrode polishing, in order to characterize the electrochemical properties of an unknown quinone molecule. So, as I said, ORGANA consists of multiple different components, and there are four main ones. I'll go into a little bit more detail. Phase one is based on experiment reasoning between the human and ORGANA. So here, ORGANA has several goals that it needs to figure out in order to be able to execute the experiment. And these goals include the purpose of the experiment, what reagents and equipment that ORGANA has access to, an example of how to run one step of the multi-step experiment, and then finally the stopping criterion. So the second step we have is perception grounding. So this is where ORGANA perceives a scene, segments all of the vessels and tools that are in the scene, and then asks the human what each vessel is used for. Then we have the third phase, which is robot execution. So here, ORGANA, given the experiment plan, uses task and motion planning to come up with the actual robot code. And here we use PDL stream, and we also use a parallel planner in order to figure out how to parallelize some of the steps. And then finally, once the robot is done the experiment, we have an analysis phase where we generate a report for a user. And we also, depending on the experiment, do whatever analysis might be required, so we can generate plots and also reason on whether or not the outcomes of the experiment match the expected observation. And based on that, we can ping the human if something is weird or going wrong. So here's a video of ORGANA actually working in the real world. So here in this first phase, I'm interacting with ORGANA to figure out the goals of the experiment. And then there's a grounding phase where ORGANA perceives the scene. Right now it's detecting all of the tools and vessels. And then it's asking me if I can identify what each one is used for. So now ORGANA is actually running the experiment. So here is the analysis after one experiment that ORGANA is doing, and then based on the initial interaction, the human said that the experiment should be done 6 times and with different conditions, and so now ORGANA is doing the remainder of the experiments. And now after all the experiments are done, ORGANA is generating the final report for the human so that the human can sort of have a summary of exactly what happened, as well as the final results and the outcome of the experiment. So here we did an electrochemistry experiment where the goal was to figure out the redox potential of a quinone molecule as a function of pH, and from that we can get some properties of the molecule. So here we have a plot summarizing that for the human. So we tested ORGANA doing this electrochemistry experiment and compared it to a human doing that same experiment. So we found that the results were pretty comparable, that both sets of experiments resulted in the same characterization of the molecules. And we also tested the time that it took for each set to perform the experiment. So down here at the bottom, we have how long it took the human to perform the experiment. And here in the upper bars, we have ORGANA. And so the overall time of the experiment is longer with ORGANA because the robot is a little bit slow. But if we look at how much time it took for the human to actually be involved in that experiment, which is represented by the solid color bars, it's a lot less because the human only needs to interact with ORGANA for a little bit at the beginning and maybe in the middle if there are issues, but overall that is way less time than the human performing it on their own. So we wanted to understand the impact of ORGANA as a potential lab assistant and sort of gauge whether or not chemists would find something like this useful. So we did a user study. Real world chemists first did the experiment manually, and then they did the experiment with ORGANA. And so they found that using ORGANA, they were frustrated a lot less, which is good because the experiment's very tedious. There's also a lot less physical exertion, which also motivates the use of systems like this for people with physical disabilities. And overall, they enjoyed using the system more than doing it manually, which is the goal. So to close off, this project involved so many different people over a long period of time. These are the main people that were involved in the ORGANA project, but there were many others. So a huge shout out to them. And also thank you for listening. This is the website for ORGANA if you want to find out more. And I hope you enjoy the rest of the workshop.